Hi student. So in our previous video we were talking about the what is one function, what is onto functions. So today let us go with some of the properties regarding the one and onto function and the exercise problems. So problem based upon the one and onto functions. So in my previous video I have done with some of the three problems based upon the one and onto. So I'll continue with that one first. So the some next one of the example question, so which is one of the important if you consider it for the board examination purpose. So what that question is saying is, show that the function f from set of natural numbers to set of natural number where that function is given like this: x plus 1 when x is odd and x minus 1 when x is even, and we need to show that this function is a bijective function. Bijective means what? The function is both 1 and onto. So we need to prove this one, that is this function is a 1 and onto function. So one thing which we need to remember is when the function is defined like this, means which is having two or more functions, the function is defined. You can see here for the x we are having two functions when x is odd, when x is even. So when the question comes in this manner, we used to solve the 1 and onto. We are going to prove 1 and onto in the form of cases. So let us first deal with proving the question, that is the function is an 1 function. So what are the cases which are involved here? Here we are involving with the three cases. So what are these three cases? So cases, it is nothing but you can see here the x is even, x is odd. So the first case if I say take is when x is even and x is odd. Actually the four cases will be going to come, that is one is x is even, another one is x is odd. Means 1 means how we are proving. First thing, we are considering any two numbers, that is x1 and x2, and then we are proving it as f of x1. If f of x1 is equal to f of x2 means then x1 is equal to x2. This is the process or the algorithm which I have said to prove the 1. So here we need to consider these two numbers, right? For that two numbers, here they have given the cases, that is x is odd, x is even. So the cases will be going to arise. So the thing is, one we can say this, one is x1 is even, another is x2 is odd. Another case I can say x2 is even, x1 is odd, but both the thing we are going to get the same answer. So we are considering any one, that is one is x is even, x2 is odd. And the second case, if both x1 and x2 are even. In third case, both x1 and x2 are odd. So now let us see how the we are going to prove it in each case. So first case is when x1 is even and x2 is odd. So first thing, we have taken two numbers which are different. So both are different. This one is even, this one is odd. Both are different numbers. So let f of x1 is equal to f of x2, because this is the process of proving the function which is 1. So if f of x1 is equal to f of x2, if x1 is even means what? F of x1, if x is even, f of x1 is x minus 1. So it becomes x1 minus 1 because x1 is even. x2 is odd. So what happens to f of x2? When x is odd, x plus 1. So f of x2 becomes x2 plus 1. What happens to this one? x1 minus x2 is equal to 2. You can see here our x1 is even and x2 is odd. You can check that a difference between even and odd cannot be equal to 2. It is not at all possible. This is one of the impossible equation which we have got, that is the difference between any even and odd number is equal to 2. So this case is not at all possible. It is not at all possible, so we can't consider this case. Suppose if you take x1 is odd and x2 is even, at that time what you are going to get? x2 minus x1 is equal to 2. Both are one and the same. The difference between odd and even cannot be equal to 2. So that's why I merged that two cases into one case itself. So this case is not at all possible. Now let us move to the next two cases, that is both are even and odd. So second case. So again I am starting with f of x1 is equal to f of x2. Since both are even, when x is even, what happens to our f of x? It becomes x minus 1. So it is x1 minus 1 is equal to x2 minus 1 because both are even. So minus 1 get cancels, x1 is equal to x2. So when both are even, if f of x1 is equal to f of x2, then x1 is equal to x2. So 1 1 is proved when both are even. Next, odd. So odd means f of x1 is equal to f of x2, starting with the same thing. Since both are odd means what happens to our f of x1? It is nothing but x plus 1. So x1 plus 1 is equal to x2 plus 1. 1 1 get cancels, x1 is equal to x2. So when both are odd, if we start with f of x1 is equal to f of x2, we are going to get x1 is equal to x2. So even both x1 and x2 are odd, the function is 1 1. So the given function f of x is 1 1 function in both the case. In the first case, the thing is itself impossible, so we can't consider. But in rest two case, the thing is possible, so it is not it is a 1 1 function. So the 1 1 process, the proving 1 1, it is easiest one. So we have done with the proving the thing, that is the function is a 1 1 function. The next is onto function. As I said earlier, to prove the onto function, we need to write the statement. Before writing the statement, we need to feel what is that onto function. So let us, before writing the onto function, let us feel what the function is saying. So this is the given function. They have given the set of natural numbers. So I have before doing the mapping, I have done one of the outline to understand the concept. So to prove any onto function, the thing is, whatever the function they have given, that is they have given y is equal to f of x, whatever the function they have given, we need to convert or reverse it into in the form of x is equal to f of y. So you might have observed this one in the previous video also. So here they have given the function f of x is equal to x plus 1 when x is odd and x minus 1 when x is even. So if x is odd, I will start here. You can see here, if x is odd, y is nothing but our f of x. What happens to our y? It is nothing but x plus 1. You can see here, because since x is odd, our y is equal to x plus 1. So x is odd means x is an odd number. If we add 1 to an odd number, what happens to y? It is nothing but even. So when x is odd, our y is what? It is a even number. So I am reversing this function, that is the function they have given is y is equal to f of x. We need to reverse in the form of x is equal to f of y to understand these concept. So how I am reversing? I am reversing it in the form of x is equal to what? Y minus 1. X is equal to y minus 1. Now you can see here clearly, whatever the y we have got here, it is a even number. So from the even number, if I take 1 means what happens to our x? X is an odd number. So there is no changes, you can see here clearly. Again, another case is when x is even. When x is even, what happens to our y? Y is nothing but x minus y. If we remove 1 from the even number, what happens to our y value? It is nothing but the odd number. So reversing that function, what we are going to get? X is equal to what? Y plus 1. So which is nothing but the even number, because y is odd. To an odd, if we add 1 means we are going to get the even number. So this is the outline so that you can draw the mapping easily. So now it is clear that when y is even number, you are going to get x as an odd number which is 1 less than the x. For example, suppose first I will consider the even numbers which is on the codomain, that is nothing but 2, 4, 6. These are the even numbers here. So 2, 4, 6 are the even numbers. So when y is equal to even number, we are going to get x as an odd number which is 1 less than the y. So when our y is equal to 2, the x value is 1 less than the 2, that is nothing but 1. So when y is equal to 4, we are going to get x value which is 1 less than the 4, that is 3. When y is equal to 6, we are going to get the value of x which is 1 less than the 6, that is 5. Similarly, if we go with the 8, we are going to get 7, like that. Next, even number. Odd numbers. Now I am considering the odd numbers 1, 3, 5, 7. These are the odd numbers. So if we consider any odd numbers in the codomain, we are going to get the value of x which is 1 greater than that odd number. So if I take the odd number 1, what value we are going to get as an x? We are going to get 1 added to that odd number. So 1 means 1 plus 1, it is 2. If we take odd number 3, means our x value is 3 plus 1, 4. If we take 5 as an odd number, means our value of x is what? 5 plus 1, 6. If we take 7, means here will be 8. It will go into map with 8. So you can see here clearly our mapping will be going on the process like this. You can see clearly all the numbers on the codomain is going to be get occupied in this manner. So whatever the natural numbers present in the codomain, it is going to be get occupied. So the function is what? It is an onto function. So this is the thing what I have explained. It is an outline. This is how you need to understand, and how we are going to write this one in the statement. So the statement will be like this. So first we have considered y is an even number. So if y is equal to 2r, so 2r or any number, I have taken 2r which is belonging to the set of natural numbers. So 2r means it is obviously an even number. So when y is an even number, how we are going to get x? X will be 1 less than that even number. So for any y which is is equal to 2r which is belonging to set of natural number, there exists x which is equal to what? 1 less than that y. So there exists x 2r minus 1 which is belonging to n, such that f of x is equal to y. Similarly for this one, when y is odd, I will write that odd has equal to 2r plus 1 which is belonging to set of natural number. So if we for any y which is belonging to set of natural number which is odd number, there exists x. How the x will be? It is 1 greater than y. So 1 greater than y means how it will be? 2r plus 2, because plus 1 becomes what? 2r plus 2. There exists x 2r plus 2 which is belonging to set of natural number, such that f of x is equal to y. So this is how we are going to write the statement. If you understood this one, writing this statement is not at all a big thing. So this is the statement for set of even numbers which is in the codomain, and this is the statement for set of odd numbers which is in the codomain. So by writing this one, we can say that the given function is an onto. So clearly the function, that is f of x is equal to what the function they have given, it is a bijective function because it is both 1 1 and onto. So the next is, I'll state it as a property because I'm stating the two properties here, one and another one. These two are regarded as one of the example problem in your NCERT textbook. What it is saying is any 1 1 function, a 1 1 function f from set of x to x is always onto. Means both our domain and codomain, both domain and codomain are the same arbitrary set, are any two same arbitrary set. So if I take x is equal to arbitrarily 1 2 3, if I take the set x is equal to 1 2 3, I will do the mapping. So the function is defined from set x to x. Our x is 1 2 3 and our codomain is also 1 2 3. What they are saying, if that function is 1 1 means, then obviously it is also an onto function. 1 1 means what? All the elements in the domain should have one and only one image in the codomain. So I can do mapping as I wish. Suppose if I do like this, or else if I map 1 with 2, 2 with 1 and 3 with 3, as usual, whatever thinking you can do with the mapping, you can do it of the mapping must be 1 1, that's all. So the function now what I have mapped here, it is a 1 1 function. So the function, it is a 1 1 function from f from x to x. Obviously it is an onto function, right? Because whatever the elements which are present in the codomain, all are occupied. Means all the elements is the image of one of the element in the codomain. So all the elements in the codomains are occupied. So it is an onto function. Clearly, in other words, if I am saying means both domain and codomain are having same number of elements. So 1 1, if it is a 1 1 function means obviously each element is having only one image. So same number of element, each element is having only one image means all the elements of domain and codomains are occupied. So it is a 1 1 function. Since it is all the elements of the codomains are occupied, it obviously becomes the onto function. So that is what the property is saying. The next is onto function f from x to x is always 1 1. So another statement is nothing but if a function f from x to x is defined, which is an onto function means, then it is an 1 1. Suppose if I am taking x is equal to 1 2 3 and I am defining the function f from set x to x, that is 1 2 3 1 2 3. Suppose if I define, since onto function, the function should be onto. Onto means what? All the elements in the codomain should be occupied. Suppose if I take a function like this, clearly all the elements in the codomains it is occupied, but they are saying it is always an 1 1 function, but 2 is not occupied. Clearly observe here whether it is a function. If you do the mapping like this, no, it is not at all a function. Why it is not at all a function? Because according to the definition, what if you write it in the ordered pair means how it will be? 1 comma 1 1 comma 2, it will be like this, right? 1 comma 1 1 comma 2 1 1 comma 2 3 comma 3. This will be if you write it in the order. Whether it is a function? No, because what is the definition of the function saying? No two ordered pair should have same first element of the ordered pair should not be same, but here we are observing that these two elements are having same first element, that is one is having two images. No elements in the domain should have two images. So it is not at all a function, it is a relation, but it is not at all a function. So this case is not at all we are going to get consider. Suppose if we consider 1 2 3 1 2 3 set x set x. Suppose if we do the mapping like this, suppose if we do the mapping like this, this type of mapping is also not at all possible, because they have said the function is onto. Function is onto means our 2 must be also should be occupied. So even this type of mapping is also not at all possible. So if we do it in the whatever manner, finally to make it an onto function, our mapping it should be like either like this or the mapping which I did here like this. In either way the mapping should be like this. So if it is like this means obviously it is an onto function. Clearly each element in the domain is having the one and only one image in the codomain, so it is an 1 1 function. So to write it verbally means they are using the contradiction method. So how they have stated means, suppose if any two elements in the domain is having the same image, that is like this case, it is a contradiction case, what I said already. How means, here 1 and 2 both the elements are having the same image, that is our f of 1 is also equal to 1, f of 2 is also equal to 1, and our f of 3 is equal to 3. So if we write the means if it is like this, contradiction means what? What we have assuming means the function f is not 1 1 function. So function f is not 1 1 function. We need to prove it as a 1 1 function, right? Suppose if it is not a 1 1 function, then what happens? Our mapping will be like this. So if the mapping will be like this means what I have did here, that only I have written the mapping. So Now if you write what is the range of this function, means what you are going to get the range element, that is 1 and 3 only. So the range is not equal to codomain. So when range is not equal to codomain means it is not an onto function. So it is not an onto function means it becomes a contradiction, because what the question is saying, it is an onto function, but what we got here, it is not an onto function. So it is a contradiction to our assumption, hence the given function is an 1 function. This is how we are proving it verbally. Understanding purpose, this mapping is enough. To proving it verbally, these things matters.